Okay, thank you very much for inviting me to make this presentation today. This is a joint work with two colleagues from the United Kingdom, Catherine Donnelly and Jens Berg-Nielsen. And today we are going to talk about this fundamental cost and risk that matter to pension savers and life annuitants. What we really want to do in this contribution is to present to you a problem that all pension savers have, and we as citizens, we all face, the problem of accumulation of an investment during many years. And this is our fundamental question. Let's see if let's go back. The fundamental question is, how much wealth is available at a certain time point in the future, okay? So on this slide, I just want to briefly mention to you three previous works that we have already done together, where we have addressed different problems around the same question. One of them is just talking about the chance that this wealth is dramatically low just before retirement and due to market conditions. So the stock exchange just drops and we are suddenly very poor. We have also looked at other issues like the consequences of very high managerial fees that have an impact in the long term, because those fees that we pay every year accumulate over time. And the third thing that, all these messages, you can find them around those papers. The third message is the difficulties about communicating all these uncertainties to consumers, to citizens. So, when we started to work on this particular paper, we had the objective that you can see here in red, and this is to design a completely different transparent strategy for the long-term investment of savings towards retirement. So this is what we aim, and we try to cope with all those questions that we have already worked before. So in my talk today, what I will just present is very briefly this motivation. I will just skip all the technical details and just drive you to the main result, get to you to see some numbers and some flavor of what we have done. I'm a little bit afraid that by presenting this in this way, you may feel it's very easy, but I can tell you the mathematics behind that are not easy at all. Okay, let's start talking about these 4 points. Since I'm coming from the European Union, from Spain, and also due to my co-authors from the United Kingdom, I want to mention that the European regulatory framework mandates that customers from insurance companies and pension funds, they have to understand the coverage that they have bought. They have to understand the uncertainty and the conditions of the contracts that they have underwritten. And we have identified at least 4 factors that threaten the understanding of these investments that we do on our normal lives. First of all, is we can find the fees problem. The main problem about fees is that the general ignorance about the return that is lost due to the payment of these regular fees. There is also a lack of transparency that I think we should call the regulator to try to do something about this. Second problem is the duration. Of course, when we face investment related to retirement, we always have this uncertainty about longevity, also what time horizon we're talking about. Third thing that we really want to address as well is the return, but with some kind of risk adjustment. So we don't really want to forget that choosing a measure of performance should also include some idea about the risk that we are taking. And so what we propose in our contribution is that we should be measuring things using percentiles or quantiles. And this is what we are going to see now. And the last factor that I want to mention is that we should be somehow smoothing things, making things less volatile. We know risky assets are volatile. We don't like this instability, and we don't want to lose too much on our savings, so we want to have some kind of security on that side. So maybe this is too ambitious. When we started working on this, we were mainly concerned about the fees, the first factor, and this is the one that I will consider with more depth. Okay, let's see an illustration of what we have done. Here on the left, you can see a case of two people who have invested for 30 years $300. You can think about $300 million if you want, but okay, let's say 300 units, $300. And over 30 years, the path of those people is very different. The one on the upper side ends up having a very large amount. Although it has been going up and down, the final wealth is very high. On the other side, you can see someone who has been not so lucky. On the lower side of the left picture, that person that follows this red line has lost practically half of his wealth. And this is an unconstrained case, and we can see this with just regular investments on different kinds of assets. How can we control this risk? So what we do in our paper here is we fix two bounds, an upper bound that you can see here with this dotted line, and a lower bound that you can see with this dashed line. And what we force here is that our investment always stays within those two limits. So we propose an automatic mechanism that will guarantee that we will never cross the lower bound and we will never cross the upper bound. Of course, the upper bound won't be a problem, but this is the price we have to pay to get more security on the downside. Okay, the magical feature about this method that we have described in our paper is that it is a strategy that can be carried out individually. So we do not need to be in a group. We can carry out this investment strategy on our own, or even in different accounts. We can have with different time horizons, with different levels of payment. Okay, so we don't really need to mutualize, if you see what I mean. Okay. Here is the mathematical part. So what we have done here is we have assumed a market model, an investor. We have solved the problem with the upper bound first, which is easier to solve, and then we have solved the problem with the upper and the lower bound. And what we offer you is this formula, which is telling you exactly at every time point what is the investment that one has to do in the risky assets. Okay, the proportion of the wealth that has to go to the risky assets. And you can see the details in those two working papers. But I prefer not to go into this, which could be very long, and show you the numbers on this table. Okay, I will spend a couple of minutes on this table. Here you can see this example where we have people investing for 30 years. The initial investment is $300. And what you have on the first column is the tolerance level. And if you look at those two red figures that I just flashed, you can see that there is one person out of 100 that would lose 2/3 of the initial wealth and will end up having less than $82 after 30 years with no constraint at all. Okay, just investing, one can be unlucky and get, very, very low wealth at the end. On the other extreme, 1 out of 100 also, there would be 99 in between, but 1 out of 99 individuals would be very rich in this unconstrained case. So if you understand what I mean by this first column, then you will understand very, very easily what happens in the other columns. Next is this one, the third column, where you can see that we have fixed the lower bound. So no one following this strategy can fall below 250. So as you can see here, about 30% of the people would lose some money, but not more than 50 units, than $50. On the upper side, we have no constraint here, so we can go very high, but not as high as before. And if you look at the third column, we do the other exercise. Now, we put the upper bound, so we cannot go too far up, and we would expect to be much better on the bad side, on the extreme bad case, but we don't. And this is why we propose to have the two bounds, where we say, okay, we want our wealth at the time horizon of 30 years to stay within those two limits. 250 below, which will just capture about 20% of the people. And then an upper bound, we say we don't want to go above 587, which is about double the initial wealth. Okay, so this is how our mechanism works. Of course, we can choose those two bounds according to our wishes. And here you can see this also graphically. On the left, I don't want to go into too much detail about the left part of my picture, because this one is used when we want to compare different bounds, upper and lower bounds, how the quantiles work. But what I really want to show you is the picture on the right. Okay, now look at the picture on the right, because it will start moving. Okay? We will see every year how our wealth distribution evolves. This is what happens after 1 year. The first year, remember, everyone had only $300. And then after 1 year, some people have lost, some people have won some money. Then we are around that number. Okay, now I will push, and hopefully this works. So we can see evolving the distribution over time, over the years, until we reached year 30. Okay, and this is what happened at the end. So at the end of the 30 years, we know that 20 out of 100 people would be on the lower side, and then some people would be distributed in the middle, and then there will be 30% that would be on the upper side. But we somehow have restricted the behavior just using this mechanism. All right, so I'm coming to the end. What is the advantage of what we propose here? The advantage is that it is automatic. And I want to make it very clear that we still need fund managers, right? But fund managers don't have to worry about risk the same way they would worry in the past. They can concentrate on enhancing the returns. We can pay them to look at that part. Don't worry about the risk. The risk will be under control within those two bounds. Second, the advantage of this method is that it allows for this smoothing interval. So what we say is that we know that our savings will not go above or below that level. Easy to communicate. I want to stress that the time horizon plays a crucial role. I want to be very honest. This is the point where we are actually working at. We still haven't found a way across this restriction, but I'm sure that we will at some point. And this part is easy. We can also implement regular payments instead of what I just presented to you, which is the simple case where we only have one payment at the beginning. And I want to stress again, what we do is smoothing without pooling. So anyone can do this. You don't need to be in a group, although we can also benefit from being in a group when doing this investment. But it can be implemented on an individual basis, and that gives much more freedom to pension savers. Okay, conclusions. I just want to stress now the main messages. This investment strategy that I presented to you is different because traditionally, investment strategies have been dominated by the maximization of expected returns with some control and risk when approaching the retirement age. But our method addresses the control of risk from the start of the savings period. So we just do that from the beginning. We also believe that it is much easier to communicate the extent of uncertainty to consumers using those bounds on the desired final income. I have to stress that what I have told you was without any inflation. I didn't introduce the problem of having an inflation index in our examples, but I think doing it in this way is transparent and easy. Also, I want to advocate for the use of quantile plots, which I didn't have much time to present today, but the sort of examples that I was giving you, because this helps the pension managers to understand how risk works, but also the pension savers. And finally, my last question, last conclusion is that our proposed mechanism does not need to be implemented in a way that we have to pay for the fund manager to worry about the reduction of risk, but rather we just want him to or her to improve risk-adjusted return. And this is the end of my presentation. I just want to let you this picture. This is from my hometown, Barcelona, where we have a lot of work in progress, and I hope you understand this is also work in progress. Thank you.